First of all, I hope you guys got a chance to see what are the topics that we are planning to cover today, and that starts with a quick recap of what we learned with respect to invertible function, composition function, and then what is the correlation among them, and then we'll jump on to unit 2, which is nothing but the start of trigonometry. So if you look at pre-calculus, it's a mixture of each and everything that we learn in maths, right? So that's what forms the base for calculus. So we will end up learning a lot of things that we would have partly learned or not learned, but that will make the base for us. All right. Um, so in the previous class or in the first unit of this one, we learned about composition function or composite function, and then we learned about inversible function. Now, if you look at the first one, composition function, that's nothing but function of functions, meaning a composition of functions where you have multiple functions imposing or superimposing over each other. So function of functions, if I can say it in short. An inversible function is where you have a function which has domain, I mean the set of values, the input values, which gives you a range, and when you invert them, your range becomes your domain, and that gives you a corresponding return value, same as domain, same as what you have in domain. So basically, it's you're inverting the function. So whatever is your domain and what is your range, if the function x gives you this domain and corresponding range, inverse of this function makes this as your domain and this as a range. And this is a summary of what we have learned. Correct? Now, let's try relating that with real life scenarios. You should not be learning composition function just as a topic or a concept, and then you grapple with yourself to figure out where exactly you want to use it. Simple answer to that is, all of you, whoever has dealt with, let's say, a classic example of laws of motions or velocity, acceleration, whatever you guys would have learned, where you see this gives you the value of a, which is acceleration, which is v minus u by t. And again, I'm not trying to teach you guys physics, I'm just helping you relate it. Okay, this is acceleration, and when you talk about force is your mass into acceleration. So see here, this a is a function of these three inputs, and that derives your acceleration. And then you put the value of acceleration and multiply that with mass, which gives you a force needed for generating acceleration for something with a mass. So this is a classic example where you can see that force is a function of mass and acceleration is a function of these things. So basically, if you relate it, it becomes force equals mass into v minus u by t. So this is one function, this is another function, and this function is actually a function of two related or extendable functions. So this is a classic example where you will see that one thing is a function of something else, and something else is a function of the one that you have talked about. So these two are like two levels of hierarchy that you would see, and that's where it relates back to the concept of composition functions. Yeah. Moment of silence is what I call it. Everybody with me?
Yes, sir.
Oh, yes, sir. Okay. Now, same way, inversible function, as the definition says, you have one domain, you have corresponding range, one-to-one mapping, you inverse it. So your input becomes your output becomes your input. That's in summary inversible function, and that's pretty much possible. It's like if you give some value, you get some corresponding value. What if you change the side and then relate it back? So this is just a summary of what we have learned, and then in real life how do you relate it is what we were trying to cover. So we have covered first unit of pre-calculus, Again, in Khan Academy, if you go to math, high school and college level courses, that you will see a link for pre-calculus. This is unit 1 that we have covered. And I would request each one of you to just go and do all the unit tests within that unit. Not because I'm forcing you guys to do it, but it's going to be a way for you to ascertain that whatever you have learned, you're actually able to solve the related problems, and your level of concepts understanding is good enough for you to be able to solve relevant questions. Okay, uh, it is again not a mandate because you guys are all grown ups. I would not kind of do any policing here to say no, have you done it, can you show me, kind of a thing. But then it's my earnest request to you guys to make sure that you do that unit tests, all the unit tests within one for unit 1 of that syllabus, and let me know if there's something that is confusing enough to give me another chance to teach you guys something that I could not cover. Is that okay? Okay. Alright. So when you guys say yes, that means yes. If you don't say anything, that also means yes. So I'm assuming whoever is not responded to it is saying yes only. Alright. So let's move on to unit 2, which is nothing but the foundation of trigonometry. And here we will learn certain things that we would have learned before, but we will try relating that with the concept that we have learned before versus what we learned new. So now we talked about the relationship between degree and angle in degree and angle in radian, correct? And I'm sure you guys know it. If you don't, this is the only thing that I would want you guys to remember. So 360 degree equals 2 pi radian. So you can always represent degree or radian depending on what is the premise of the question that you have been asked to solve, or how you have to interpret that as part of the question. But there's no rocket science here. 360 degree, basically one circle makes 360 degrees, one revolution of the circle makes 360 degrees, and if you want to represent that in pi, you say 1 pi here, 1 pi here, so basically 2 pi's. 360 degrees equals 2 pi. Now, if I say find out the value of sine 30 degree, sine pi by 6, that is nothing but sine 30 degree. Yeah. If I say sine pi by 4, it is nothing but sine 45 degree. If I say, we have done enough of sine. If I say cos pi by 3, it's nothing but cos of 60 degree. Yeah? No response? Yeah. Okay. So let me not bore you guys with this concept. But then here we will try learning about the unit circle in terms of trigonometry. So let's look at, let's say if you're talking about sine of pi by 4, which is nothing but sine 45 degrees. In terms of unit circle, if I say, let's see how to find out the value of this. Have you guys come across this in the past, or you would want me to start or try helping you guys relate it back to what you would have learned in the past?
I've learned this before.
You have learned this before. Okay, so let's quickly look at. I'm sure you have many of you would have learned, but I will still spend next 15 minutes to go through this, and then we'll come back to the unit circle and then try relating with that and some of the concepts that you might find interesting. So first of all, everybody knows if this is my theta, sine of theta equals, let's say if it is A, B and this is C, is A by C, cos of theta equals B by C, and so on and so forth. Yeah. Now, if you have to find out sine of 30 degree, we did that in the last class, so I will. I'm sure all of you were there in the class, in the SAT class, but we will just try proving that in terms of so this is an equilateral triangle. This is, let's say, this is L, this is L, this is L, meaning every angle is 60 degree. We are trying to find out the value of sine 30 degree. What I will do is, from here I will draw a perpendicular, which, let's say, this is A, B and C, and this is D, meaning this is 90 degree and this is 90 degree. So what we see is this side of the triangle, meaning ABD, and this ADC, both are congruent, because this both are right angle triangles and this is common, and the hypotenuse is also same. So these two are congruent. From that we find this length is L by 2 and this length is L by 2, meaning from here to here is L by 2, here to here it is L by 2, and we will use that to find out, let's say, and when these two triangles become congruent, that means this angle will be equal to this one, and which will be like each angle is 30 degree. So sine of 30 degree will be equal to this divided by hypotenuse, which will be L by 2 divided by hypotenuse, which is L. So that makes it 1 by 2. Similarly, this length again, sine 30 is 1 by 2. Sine 60 degree. Sine 60 degree, if you have to find, that will be, this is 60 degree. So this side divided by this side, and this side will be equal to, let's say this is k. So k equal k square plus L by 2 square equals L square, as per the Pythagorean theorem. So from this we find k square equals L square minus L square by 4, which equals 3L square by 4, and hence k equals root 3 by 2L. So from this we find sine, this is root 3 by 2L divided by L, and that gives you sine 60 equals root 3 by 2. So I'm just rushing through it because we have done this in the past. I'm just helping you guys recall this one. So from this, I mean, we just know that, okay, sine 30 equals, sine 30 degree equals 1 by 2, and sine 60 degree equals root 3 by 2. Okay. Now, when we look at the unit circle, and then you use this concept, this is your radius, and let's say if you're talking about sine pi of 6, which is nothing but sine 30 degree. So you are making a 30 degree angle. This is 30 degree angle. So from this also you can find out the value of sine 30 degree. So same thing you will do. You will draw a perpendicular here, and then same approach like how we proved. You can again put another radius here, join these three, 30 degree here, and then from that you can find out. But I'm not trying to prove that same thing again. What I'm trying to find out is, tell me what is the coordinate of this point when it's sine, let's say 30 degree. What is the coordinate of this point? X and Y coordinate. Let's say this is your center. So does anybody know what is the X and Y coordinate of this one in terms of theta? I was going so very fast. I'm not sure if I confused everybody.
I understand this, sir.
Okay. And again, the reason why I was going fast was just to make sure that I'm not wasting your time. Yeah, Shwari.
Is it root 3 over 2 comma 1 half?
Okay, that could be the answer, but how? Is there a way we can generalize this?
Is it because it's a right triangle? So because of the line you drew
Okay.
on this, the opposite, the side opposite to 30 degrees is perpendicular, and that makes a 90-degree angle, meaning that it's a 30, 60, 90 triangle.
Yeah, you are going the right direction, but I want more specific answer. So let's look at this. So does anybody, okay, so Ishwari has given a good response. Anybody else? If I'm saying I have, let's say, 30 degree here, can somebody tell me what will be the x and y coordinate in a generalized term, in a more generic term? Root 3 by 2, command 1 by 2, that might be the answer, but that is still not a generic answer for me. Okay. Let's look at it. See again, you all know sin 30 equals 1 by 2. Yeah? Sin 30 degree is 1 by 2. Everybody with me so far, right? Similarly, cos 30 will be equal to cos 30 degree equals how much? Any of you remember? Give it a try. We have talked about that in the previous class. See again, if I have given you sin 30 and sin 60 degree value here, you have noted it down. What happens is cos of complementary angle, sin of theta is equals cos of the complementary angle. Yep, Ishwari, yep.
Is it root 3 over 2?
Yes. So sin of 30 will be equal to cos of 60 or vice versa. Okay. So every angle, see, this is the rule of complementary angle, that's what we have done in previous class. Meaning, I hope you guys don't want me to prove that, but I don't get confidence. If this is theta, what will be this value? 90 degree minus theta. And these two angles are called complementary angle. Correct? If this is A, this is B, and this is C. What do you see here? Sin of theta equals what? Sin of theta will be A by C. And if I look at this one, let's say cos of 90 and cos of theta will be what? Cos of theta will be B by C. Are you guys able to follow me? I mean, just stop me if I'm going way too fast.
I'm following, sir.
Okay. Dave, Chris, Rehan, everybody is able to follow me?
Yeah, I'm good.
Okay. So, see here, cos of complementary angle, cos of 90 degree minus theta will be what? I'm taking this as angle, 90 degree minus theta is this angle. Cos of this will be what? Base by hypotenuse, which will be A by C. You see that these two are having same value, A by C, right? So this is called the rule of complementary angle, meaning sin of theta will be equal to cos of the complementary angle of the theta. That means if by any chance you know sin of 2 degree equals, let's say, something x, this will be equal to cos of 90 minus 2 degree. Okay? Will be equal to this sin of 2 degree, and it will be equal to x. Sin of a theta is equal to complementary of cos theta. Okay? Complementary of this theta actually. So that means this 2 degree, so it will be equal to cos 90 degree minus 2, which will be cos 88 degree. If you get sin 13 degree, how much that will be equivalent to in cos theta? Quick math. How much sin 13 degree will be equivalent in cos of theta? In terms of cosine, basically. Yep, Chris, go ahead.
I don't know, would it be 88?
I'm sorry?
Sorry, would it be 87 degrees?
It will be cos of 90 degree minus 13. Whatever it is. It will be 77.
77 on my website.
Yeah. So always look at this. Whatever value you have in sine, take the degree out, subtract that from 90, that will be the equivalent value in cosine actually. Yeah. So what I was trying to do here, let's come back to this one. So from this we know sin 30 is 1 by 2, cos 30 will be equivalent to sin of 60. Cos will be equal to, cos 30 will be equivalent of sine of the complementary angle 90 minus 30, which will be sine of 90 minus 30 is sin 60. What is the value of sin 60? Root 3 by 2. Yeah. Now look at this theorem. Then look at this circle. So we know sin 30 is 1 by 2, meaning this side is half. Let's say this is radius by 2. Similarly, cos 30 is equal to sin 30, cos 30 degree is equal to sin of 60 degree, which is equals root 3 by 2. Meaning this portion here to here is root 3 by 2 of r. Yeah?
Yes.
Yeah. Now look at this value, this point. What is the x coordinate? If this is my x and y coordinate, what is the value of the x coordinate? This length, which is root 3 by 2, right? And what is my x coordinate? X coordinate is this height, which is, let's say root 3 by 2, sorry. This length is root 3 by 2 of r, and this length is, this y coordinate is r by 2. Now you look at this point's x coordinate root 3 by 2 r, and this is r by 2, meaning the x coordinate is r times cos 30 degree, and y coordinate is r times sine of 30 degree. You pick any point. See, what happened was, this became your x and y coordinate is radius times cos theta and radius times sin theta. Meaning, if you take a circle and pick any point here and see what is the angle, the x coordinate of that will be radius times cos theta, and y coordinate will be radius times sin theta. So this is how you can find out the x and y coordinate in a unit circle. Any point that you pick up, just see what is the angle that it makes with the diameter, with the horizontal line, and then your x and y coordinate will be radius times cos theta, and y coordinate will be radius times sin theta. Now it calls for a moment of silence. Let me see who all is with me. And it's okay if I confuse you guys. It's my job to take out the confusion. I don't mind explaining one more time. Yes, Dave.
What was the y value again? Sin theta times what?
Sin theta times r.
Okay, thank you.
So as I have a really bad habit of repeating things, right? So let's look at it one more time. This is your circle, and this is your x and y coordinate. This is your center. If I am saying this is 30 degree, I am just picking up a number where we know the value of the sine and cos theta. If this is 30 degree, that means this is a, let's say this is radius, so this will be half the radius by 2. This will be root 3 by 2 times the radius. That's what we have learned. No? If I am talking about a right angle triangle, what is the value of my sin theta? This is, we have learned that sin 30 degree equals 1 by 2. So from that we are able to relate that this is my height of the this point on in the y-axis, and this is the the distance on the x-axis. So if you want to know that, now since we know we related that with sine sine 30 degrees value, we see that this length by radius will be 1 by 2. That means this length is radius by 2. I mean this is my y coordinate, and this is my x coordinate, which is root 3 by 2, like what Ishwari said. Now x equals root 3 by 2 times r, and y equals 1 by 2 times r. Root 3 by 2 is in terms of theta, this is 30 degree. So root 3 by 2 is cos of 30 degree times r, and 1 by 2 is sine of 30 degree. So that is how x coordinate is cos of 30 degree times r times cos of 30 degree, and y is r of sine 30 degree. Yes, Chris.
Oh wait, could I just know what did you get below 30 degrees on the circle thing?
Here,
No, on the graph, like the actual graph.
this one, root 3 by 2. Root 3 by 2 times r. So, do you know why I'm putting that value there?
Yeah, I do. Like it's because of 30, 60.
30, 60, right? So this is r by 2. This is r. So if you look at the Pythagorean theorem, this square plus this square will be this square. So from that we get this value as root 3 by 2 times r. Yeah. So this gives you x and y coordinate. So basically, if you're talking about any circle, now the blind rule that we can follow is you don't have to do all this calculation, but based on whatever we have seen, any circle that you pick up, if you have to find out the x and y coordinate of any point, you will say, okay, fine, my x coordinate is r times cos of theta, and my y coordinate is r times sine of theta. Yes, Ishwari.
Is this unit in the Khan Academy Unit 1?
It's in Unit 2. It's in Unit 2. This is the first chapter of Unit 2.
Okay, thank you.
It's called unit circle, and this trigonometry unit circle. So this is how it starts. Okay. All right. So let's look at what else we wanted to learn today. All right. Yeah, Ishwari.
Is it possible to cover probability as well?
Yes, we can cover probability maybe in the next class.
Okay, thank you.
Because any topic that I pick up, I have to just make sure that I don't just scratch the surface. I go into the depth enough to make sure that you're able to relate with the topic. I mean, I can talk about probability, for next 30 minutes, but will that cover all the aspects of probability that you want to learn? Probably not. So we'll go through that. Okay, we'll do that in next class. Keep reminding me. So we can do that in the next SAT class also. We can do that in the next SAT class. If that is
And
okay.
where would I find the word problems? Would that also be on Khan Academy for probability?
Yes, so you have word problems also in Khan Academy in the unit test. So basically, every concept that we learn, you will see when you start doing the unit test, you will see different levels of questions being asked as part of the test. So for any word problem, right, you can, whenever you get stuck, you can ask me for explanation. I can always try solving it, but my approach is always this, and I don't want to talk about it. I would not, because where any word problem, right, all the concept that we learn, it's all about reading the question again and again, and read the question and then translate that into a mathematical formula, and then you should be able to solve it the same way. So basically, any word problem that you deal with, It's all about practice and making sure that you're reading the question a couple of times, because if you read that and extract all the information from the question, then solving that problem is not a big deal. Yeah.
Okay. Thank you.
And to all of you, right? I might run away by just giving this tram concept and say, okay, just apply tram and here, but no, not that way. I want you guys to challenge me or send me some questions. Say, okay, fine, I have done this chapter, I have learned these concepts, I applied that, but I'm getting stuck in a word problem. Or let's say you find something where you think that your teacher might fail. Give that challenge to your teacher, right? And you might have one way to solve it, I might be able to solve it some other way, and when you look at both the solution approach together, then you'll have two options to choose from, whether you want to go with your approach or if you find my approach better or vice versa. Yeah. So I will keep on teaching concepts. I will make sure that I give you guys some good problems to deal with, but then always look for solving problems and circulating problems within this group also, right? I mean, let's say Arya solves 5 problems and she finds 2 of them interesting. She can say, okay, fine, I have solved this one, but do you guys want to take a look at it? Try taking a look at this problem and see if you have a better way of solving it. And in a way, it's a very healthy competition, right? Each one of you, whatever score you get in your SAT, that has nothing to do with what others get. It's your absolute score. And how that score will improve is by you practicing more, you collaborating a little more with your friends, extracting some of the best practices, because everybody solves a problem in a different way, okay? And every problem can be solved in 5 different ways. So when you solve your way and then challenge others, say, okay, can you solve this problem? And see how people are solving it. You might find something interesting there. Yep. Alright, so let's go back to unit circle. So we looked at how to find out the x and y coordinate here on a circle in any point of the perimeter. Now, so we looked at sine 30 degree. We looked at same way you can also look at, see here, this is r, this is r by 2 and this is root 3 by 2 times r, here to here. So if this is 30 degree, this will be 60 degree, and from this you can find out the value of sine cos 30 degrees, sine 60 degree and cos 60 degree as well. Right? As soon as you have derived this value, it's fairly straightforward to find it out. Right? Now, same way, if you are talking about 45 degree, sine 45 degree or cos 45 degree. So we have learned